coveted gemstone and are found in various places around the world, including Africa, Asia, North, and South America. We've already made a video here that shows 7 places that are open to the public where you can find diamonds and other gemstones such as rubies, opals, and sapphires, as well as other videos where I show you firsthand what indicates the presence of diamonds in a particular region. For example, garnets, diopside, mica, white quartz, kimberlite fragments, and other minerals that indicate the presence of diamonds. And in case you didn't know, one of the most accessible places to look for these indications I just mentioned is in rivers, including those that have dried up. And here's why. If you take a diamond and a river rock of the same size, the diamond is going to be much heavier. So as much as the current has the power to carry the diamonds for miles downstream, at some point that diamond is going to end up sinking between the river rocks and getting buried in the gravel. And I say that because you can find diamonds anywhere along a river as long as you look in the alluvial deposits, better known as alluvial fans. In other words, to simplify things, these alluvial deposits are the gravel that accumulates in the riverbeds and bends of rivers. But despite all this, people still have doubts about how to find and identify real diamonds in nature. No wonder, because finding diamonds, although rewarding, is not an easy task, as they are rare gems, since their formation depends on extreme pressure and temperature conditions. However, many of the places where diamonds can be found have never been explored. So in today's video, I'm going to answer all of your questions so that you have the minimum knowledge necessary to find out if there might be diamonds in the rivers in your region. So stick with me for a few more seconds because this video is going to change the way you look at things. Before you start, you need to identify the diamond indicators, which I'll explain in more detail below. But to start prospecting, all you need are sieves, which is certainly the easiest and cheapest way to start looking for diamonds. If you can get your hands on 3 or 6 different size sieves, you're good to go. But now let's talk a little more about the most accessible place to find a diamond, which is river alluvium. And to do that, you have to identify the minerals that are present in these alluvial deposits. Just look at how they are full of stones and gravel, sand and silt. That's where diamonds can get trapped, often buried by all that material because of their high density. So if you use the sifters that I've mentioned here on this river, you may be able to find a diamond or some other rare mineral like rubies and sapphires. And as I've said in other videos, these alluvial deposits were usually formed millions of years ago. And that's why diamonds and other precious minerals like gold and titanium can be buried in this alluvial gravel. Now answer me a question. Have you ever seen this type of gravel in a river in your area? If the answer is yes, then stay tuned because there is certainly a possibility of finding diamonds in your area. But don't get me wrong, the goal of this channel is to encourage you to develop this incredible and therapeutic hobby that keeps you in touch with nature. As I've said before, diamonds are hard to find, but this is the kind of information that can change your financial life forever if you find a good diamond in the wild. But the best diamonds are found in underground mines. And now you may be asking yourself, but how am I supposed to find a diamond in a river? Well, let me show you. Look at this rock here. This is the famous kimberlite rock. If you find one of these rocks in your area, there's a good chance you'll find diamonds nearby. These kimberlite rocks are nothing more than lava that comes from the Earth's mantle through volcanic eruptions. In this process, the diamonds that are formed in this region end up being brought along with this lava, which when it cools ends up trapping the diamonds inside. However, over the course of thousands of years, the forces of nature end up fragmenting some of the kimberlitic rocks, releasing the diamonds trapped inside. The diamonds are carried by the wind, torrential rains and downpours to the rivers, where they are deposited in the riverbeds or even on the beach. In the same way, diamonds that have been detached from a kimberlite by erosion and fallen into the riverbed can be carried to the beach by the current of the water. But what about diamonds found in rivers? Well, that's where you're going to need those sieves I mentioned earlier. You're going to find a clean spot with no rocks around. Then you're going to dig up the earth a bit to remove the gravel from the alluvial deposits. And you're going to start sifting the material. Start with the largest sieve and work your way down to the smallest, always keeping the smallest sieve under the largest so that the material that passes through the mesh of the largest sieve is caught in the smallest sieves. If you can get 5 or 6 degrees of screen, That would be even better. But let's assume for the moment that you're in an actual river with flowing water. Diamonds found in underground mines have a hexagonal shape with 6 sides like this. However, diamonds found in alluvial deposits, whether in dry rivers or flowing rivers, are rounder than diamonds taken directly from kimberlites. Diamonds found in rivers look like a semi-polished stone. Despite being the hardest mineral on Earth, they also suffer from the effects of thousands of years of wear and tear from friction with the other stones in the river. But then you may ask yourself, how can I tell a diamond from other common stones? It's easier than it sounds. There is one characteristic that only diamonds have, and that is their metallic luster. Take a look at the difference in luster between a rough diamond and other common stones. Can you see how metallic a diamond's luster is? I'm sure that if you find a diamond after watching this video, you will have no doubts. Of course, you'll need to do further tests to certify the diamond, but learning to look closely at the metallic luster of diamonds is more than enough. It may be hard to notice at first, but over time, by watching the videos here on the channel, you'll become familiar with the metallic luster of diamonds. If you look at a diamond from a distance, it will look like a piece of polished iron, not a stone. So if you notice something glittering in the gravel of the alluvial deposits, it's a good idea to start sifting. If you're lucky enough to find a diamond, it's likely to be quite small, so try finer sieves if possible. Another important factor now is the minerals that are indicators that there are diamonds in the river that I mentioned at the beginning of the video, because not every river is going to have diamonds. But how do you know if the river you're looking for has diamonds in it? In rivers that have diamonds, you'll find some minerals that are indicators of diamonds, which are mainly garnet, chromite, and ilmenite. In previous videos, I've talked about all the indicator minerals, but these 3 minerals are enough. Garnet, for example, is a gemstone that is much more common and cheaper than diamonds and is sometimes confused with rubies. However, there are some differences. The most common type found in rivers is parope garnet, which has a reddish, dark color, sometimes grayish. And you usually find them like this in rivers, in rounded cubic shapes, with several sides, sometimes semi-polished. Like rubies and diamonds, they are quite heavy compared to ordinary stones of the same size, some of which, when clear, are beautifully cut and can be worth a lot of money. But what is important here is that you recognize and find these stones. Because garnets are formed in volcanic rocks under conditions similar to those of diamonds, they can indicate that diamonds are present in the area, just like ilmenite. This is basically an oxide of iron and titanium. This mineral is black with a metallic luster. Its shape is trigonal and it can have some facets. It looks like a piece of raw iron, is very heavy, has a hardness of about 6 on the Mohs scale, and is a strong indication that diamonds may be present. Some emenites can even be mistaken for black diamonds at first glance. The third important indicator is chromite. This is also a type of iron oxide that contains iron and chromium and other combinations of minerals. It has a darker metallic appearance, but is more irregularly shaped, more rustic than ilmenite. They are also very heavy, much heavier than other stones of the same size. It will feel like a small piece of lead in the palm of your hand.
Are dunite, which is this one, and chromite, which is this one. Now they're very similar in colour. The dunite is exceptionally fresh here, and so is a greeny black kind of colour, whereas the chromite is more of a black.
Finding chromite in rivers is also a strong indication of the presence of diamonds, as well as sapphires and rubies. That's it. You found these minerals, but how do you get the diamonds out of the river? In a practical way? Well, you put some river gravel in the sieve and then you make circular movements, turning the sieve, because diamonds are heavy, more so than other stones, and they'll end up at the bottom of the gravel, along with garnets and ilmenites and chromites, if there are any, including gold, if there's any in the river. With circular movements, the heavier minerals will concentrate in the middle, and then you just have to do this process from the coarsest screen to the finest, just as I told you at the beginning of the video. At the end, just spread out the gravel from the sieve and look carefully, because now you're going to have to see the diamond with your eyes. But how do you do it? Diamonds don't have the same luster as ordinary quartz crystals, so don't be fooled by transparent stones. Look for the metallic sheen I showed you earlier. It will certainly catch your eye from a distance. Diamonds are very small, so keep your eyes open to make sure you don't miss them. Don't be fooled by big stones. And when I say big, I mean over a gram, which is pretty big for a diamond. One more important point, when you find your first diamond, remember that it can't always be a quality stone. There are darker colored diamonds that have a lower value and others full of inclusions that will only serve as industrial diamonds. But even if you find a low-quality diamond, it's already a reason to rejoice because you're on the right track. The place has real diamonds, and it's worth looking for more. Even if diamonds are not easy to find, it doesn't hurt to try. You never know when your lucky day will come, do you? But before you rush out to start searching for rocks that could be worth a fortune, there's one last thing you need to know. A lot of people out there do find stones with serious value, but because they don't know how to properly identify the mineral type, they either ignore it or worse, sell it for a fraction of what it's really worth. Unfortunately, this happens all the time. Valuable minerals and even gemstones being sold for ridiculous prices, simply because the person holding them didn't recognize what they had. That's exactly why I created the book, Gemology Journey for Beginners. A complete, straightforward, and practical guide made for anyone who wants to learn how to identify the most common types of gems and minerals, even without professional tools. Inside, you'll learn how to perform simple tests for hardness, density, texture, and luster using everyday tools. With this knowledge, you won't need to rely on anyone else's opinion to know what you found. You'll be able to analyze your discoveries with confidence and maybe even turn this skill into a side income or long-term investment. And if your goal isn't to sell, no problem. The book also includes an exclusive collector's chart listing some of the world's most valuable minerals, their characteristics, rarity levels, and practical tips to organize your finds as your collection grows. Now, if you're still taking your first steps or just not ready to grab the book yet, that's perfectly fine. You can subscribe for free right here on the channel and keep following our videos to keep learning how to identify rocks with critical metals, which are now the new gold of the tech industry. But how can you test your diamond without investing in expensive equipment? On screen right now, you're watching two stones take the same flame and the same dunk in cold water. The one on the left fills with internal fractures and turns cloudy. The one on the right stays intact. That's how controlled heat can separate a cheap fake from a real diamond. Glassy simulants often fail under rapid heat and quench. Diamonds' high thermal conductivity and rigid lattice shed heat fast and hold up far better. In seconds, the truth shows up. Why should you care if you've never bought a diamond? Because the same logic that exposes a fake in jewelry can keep you from throwing away a rough diamond you found outdoors. A dull pebble that could be worth more than a car, sometimes more than a house. While millions buy lottery tickets, the overlooked truth is this. In the right geologic settings, your odds of stumbling upon a valuable gem and recognizing it can be higher than hitting the jackpot. Most people fail for one reason: no method. Today you'll learn the simplest, most accessible test to avoid getting fooled, and we'll apply the same reasoning to rubies and sapphires. And yes, there are 2 bonus tests that confirm authenticity for almost any stone you find in nature. Which ones? Hold that thought. For now, focus on what you see. Watch the key cues: luster, internal integrity, and reaction to thermal shock. Fakes often show trapped gas bubbles, spiderweb cracks after heat, and a milky haze after quenching. A real diamond keeps a bright glass to adamantine luster, crisp edges, and no amorphous fog. With a simple loop, these signs save you serious money. But where would I even find rough diamonds? That's the other half of the promise. In the next parts, you'll learn which host rocks matter, why certain gravels concentrate heavy minerals, and which field indicators say, stop and look. Stay sharp to the end because we'll reveal something most people have never seen laid out step by step. Fire may look simple, but it's one of the most revealing tests when you know what to watch for. Each material reacts differently to direct heat, and it's in that difference that the key lies. Glass and common simulants have high thermal expansion and low thermal conductivity. This means that when they're heated and then suddenly cooled, the surface and the interior expand at different rates. The result is visible: internal fractures, loss of transparency, and even shattering. Diamond, however, behaves differently. Because of its extremely high thermal conductivity, it spreads heat rapidly throughout its structure. This ability makes it much more resistant to thermal shock. In practice, a real diamond won't break apart or lose its brilliance when exposed to the flame of a lighter or a small torch under controlled conditions. And the best part? This is a completely at-home test. It doesn't require sophisticated equipment. All you need is a strong lighter or a portable torch, a container of cold water, a metal tweezer to hold the sample, a fire-safe surface for support, and of course, protective glasses for safety. Within just a few seconds, the difference becomes clear. Take a look at some practical examples. A piece of glass, when put through this test, shows microfractures that quickly turn into shattering. Cubic zirconia, one of the most common diamond imitations, doesn't break but loses clarity and turns cloudy after cooling. Quartz, another mineral that often confuses beginners, develops cracks along its edges when subjected to thermal shock. And that's the contrast that matters. While common materials deform or lose transparency, diamond remains stable, preserving both its brilliance and integrity. So if the stone in your hand passes this test without showing cracks or visible changes, don't throw it away. This might be the very first sign that you found something truly valuable. But before jumping to conclusions, now that you've seen how glass, cubic zirconia, and quartz react so poorly to heat, it's time to focus on the real protagonist, the diamond itself. This is the moment when the difference becomes clear even to untrained eyes. Unlike simulants, diamond does not deform, develop internal fractures, or lose its brilliance when exposed to a direct flame for a few seconds. Its resistance comes from an extremely rigid crystal structure and its exceptionally high thermal conductivity. That means heat applied to one spot is quickly dispersed throughout the stone, preventing localized stress that could cause cracks. That's why, in a quick test with a lighter or a small torch, diamond stays unaltered. While imitations show obvious signs of thermal stress, diamond keeps its appearance as if nothing happened. The adamantine luster remains strong, edges stay sharp, and under a 10 times loop, you won't find that internal fog typical of amorphous materials or inclusions broken apart by heat. But it's important to understand the physical limits of this test. Diamond is crystallized carbon. Under extreme conditions, it can change. At temperatures between about 700 and 800 degrees Celsius, in an oxygen-rich environment, diamond begins to undergo surface oxidation. At that stage, the surface may show slight dullness or loss of polish. But notice, this is far beyond what a common lighter or portable torch can reach in a few seconds. In other words, in the context of a home test, diamond will not be damaged. That detail is critical. The fire test works as an initial and safe filter. If the stone stays intact, you have strong evidence that it's not a cheap imitation. Of course, as we've seen, some natural gemstones with high hardness, such as rubies and sapphires, also resist heat. That's why fire alone is not a verdict, but it is the first major step in separating what deserves attention from what can be discarded. And this is where the question of value comes in. Picture a plain-looking pebble pulled from river gravel that survives the fire test untouched. For most people, it might slip by as just another ordinary stone. But for someone who knows what to look for, this is a sign that commands respect. Depending on its size and clarity, a rough diamond like that could be worth as much as a luxury car, and in rare cases, even a house. We're not talking about something far-fetched or impossible. We're talking about real chances, far greater than winning the lottery, especially in the right geologic settings. So if you find a material that withstands fire, never discard it without further analysis. Use a loupe, examine the luster, check for any signs of internal fractures or cloudiness. Every detail matters, and every detail could mean the difference between tossing aside a worthless rock and holding a stone worth tens of thousands of dollars. This is also where many people make their biggest mistake. They stop after the first test, and by not knowing the next steps, they get fooled. Or worse, they miss out on the find of a lifetime. That's why next we'll talk about the limitations of the fire test and how to use it properly as part of a complete identification sequence. Up to this point, you've seen how fire can quickly separate cheap fakes from something that deserves a closer look. But it's important to be clear, fire is not a final verdict. It's only an initial filter, useful for eliminating obvious mistakes and highlighting what truly resists. The trap is that some authentic gemstones can also survive this kind of test without damage. Take rubies and sapphires, for example. Both belong to the corundum family, with a hardness of 9 on the Mohs scale and a very stable crystal structure. That means they can handle the heat of a lighter or small torch just as well as diamond. If you heat a blue sapphire or a red ruby, you're unlikely to see fractures or dulling in a quick test. Under a loupe, they'll still look intact, leading to a dangerous mistake, assuming that just because it passed the fire test, it must be diamond. Another case is moissanite, a natural silicon carbide that's extremely rare in nature, but widely produced in labs and sold as a diamond substitute. Moissanite also has high thermal conductivity and can withstand heat without issue. On top of that, it shows a strong brilliance, sometimes even stronger than diamond. To the untrained eye, it can be almost impossible to tell them apart. There are others too, less well known to the general public, like spinel and certain varieties of topaz. Small samples of these stones can handle heat reasonably well as well. They don't have the same hardness or value as diamond. But if your analysis stops at fire alone, they can fool you. And this is the key point. Fire is the first filter, but it's not the final confirmation. Fire says, this one is worth checking, or this one can be discarded. It should never be treated as a full diagnosis. This is where many people go wrong. They stop after fire, convince themselves they found a diamond, and end up tricked by opportunistic buyers. Or worse, they throw away a valuable stone simply because they didn't know there were other tests available. The good news is those other tests exist. They're simple, and you can do them at home without expensive lab equipment. We'll get to them in just a moment. But before that, it's crucial to understand how to use fire responsibly and safely. The first rule is never test a mounted piece of jewelry. When a diamond or other gemstone is set in a ring, pendant, or earring, there's always metal, solder, and sometimes glue involved. Heat can damage the metal, loosen the stone, burn solder, and even release toxic fumes if adhesives are hidden underneath. The risk of destroying the jewelry is real. That's why the fire test should only be done on loose stones. Another essential rule: always wear protective glasses. Thermal shock in fragile materials like glass or quartz can make them shatter suddenly, sending sharp fragments flying. Simple eye protection removes that danger completely. Always use a sturdy metal tweezer to hold the sample, keeping your hands well away from the flame. Never hold the stone directly. Beyond the risk of burns, concentrated heat can travel to your fingers in seconds. Place the stone on a fire-safe base, like a ceramic brick, so the heat doesn't spread to flammable surfaces. And don't forget ventilation. Some synthetic materials or treated stones may release vapors or odors when heated. Testing in open air or in a well-ventilated space protects your health and avoids breathing in harmful substances. These simple precautions make all the difference. After all, it's no use saving a stone if you end up hurting yourself in the process. So the real challenge is this: how do you avoid confusing diamond with other stones that also pass the fire test? The answer is to never rely on a single test. Fire is only the first triage. It eliminates fragile fakes like glass and quartz, and it tells you which stones deserve closer study. The real identification starts when you apply a sequence of tests, and this is where beginners should feel encouraged. You don't need a lab, you don't need an advanced microscope, you don't need expensive machines. The next 2 tests you'll see are just as accessible, and together they drastically increase your chances of being certain about what's in your hand. One of them is the hardness test, which shows clearly whether the stone can scratch glass and other minerals. The other is the density test, which measures if the specific gravity matches that of a real diamond. When you combine all 3, fire, hardness, and density, you create a strong at-home protocol to separate mistakes from real opportunities. And that's the game changer. While millions still believe that diamond identification is something reserved for gemologists with labs and advanced equipment, you'll see that with the right home procedures, you can avoid the most common errors and drastically reduce the risk of tossing away a $1 million stone like ordinary gravel. After fire, the next step to confirm whether a stone deserves attention is to test its hardness. This is perhaps the most classic method in mineralogy, used for centuries, and it can be applied at home without sophisticated tools. The principle is simple. Harder materials scratch softer ones, but not the other way around. Diamond sits at the very top of the Mohs scale with hardness 10, the maximum value. That means it can scratch almost any other material, including glass, quartz, and even corundum, without being scratched in return. The practical way to apply this is to take the suspected stone and carefully try to scratch a glass surface, like that of a drinking glass, a window pane, or even a lab plate. If it's diamond, the mark left will be sharp, continuous, and permanent. It won't be a superficial line that wipes away with your finger. It will look like a cut, as if made by a fine blade across the glass. The important detail is that after scratching, the stone itself should show no wear. If the sample crumbles, leaves a white powder on the glass, or shows damage, that means it's probably quartz, topaz, or another softer mineral. A simple control test is to try the opposite. Rub the glass against the stone. Glass should never, under any circumstance, leave a scratch on diamond. If it does, then you already know the sample isn't what it seemed. This test is especially useful because it rules out a huge number of common fakes. Glass, calcite, feldspar, and even some lab-grown imitations won't withstand it. Of course, there is one notable exception, moissanite. With a hardness of about 9.25, it can also scratch glass easily. That's why hardness testing alone is not enough. It serves as an additional confirmation, showing that the stone is in the expected range of resistance for something that could be diamond. But to separate it for certain, you need to complement it with another physical property, density. The density test, also called specific gravity, is one of the most reliable you can do at home with simple instruments. The idea is to measure how much the stone weighs compared to the volume it occupies. Every mineral has a characteristic density range, and this allows you to spot differences invisible to the eye. The most accessible method is water displacement. You'll need a digital scale and a small graduated container, like a plastic measuring cylinder or even a kitchen cup with milliliter markings. First, weigh the dry stone and note its weight in grams. Then fill the container with water to a marked level and carefully place the stone inside, watching how much the level rises. That rise corresponds to the volume displaced, in milliliters equal to cubic centimeters. Now divide the weight by the volume, and you'll have the density in grams per cubic centimeter. If the result falls between 3.5 and 3.53, you have strong evidence it could be diamond. If it's closer to 2.65, it's quartz, which is much lighter. If it's above 5.5, it's likely cubic zirconia, easy to mistake by looks but revealed by its excessive weight. Sapphires and rubies, which are corundum, fall between 3.95 and 4.1, just a bit heavier than diamond, which makes the distinction possible in practice. There's also a second way to measure density, even simpler and more precise, known as hydrostatic weighing. For this, you only need the scale and a cup of water. First, weigh the stone normally in air, then suspend it from a thin thread or place it in a light mesh and submerge it in the water without touching the bottom or sides, and weigh it again. The difference between the weight in air and the weight submerged corresponds to the buoyant force of the water, which equals the stone's volume. From there, divide the weight by the volume to get the density. This method removes visual reading errors and works with stones of any shape. What's interesting is how these numbers reveal more than appearances. Sometimes a clear, shiny stone that looks precious is nothing but glass. Other times, a dull and ordinary-looking pebble can reveal itself, through its specific gravity, to be something much rarer. This is where technical knowledge outweighs intuition. Think of a practical example. You pick up a rough pebble from river gravel. It survives the fire test. At that point, it could be diamond, but also sapphire or moissanite. Then you scratch a piece of glass and the line is clear. Again, it could be diamond, but also moissanite. Finally, you do the density test and get a value around 3.52. Now the margin of error drops drastically because moissanite would read differently and sapphire would be over 3.9. The combination of these three steps is what brings confidence and reduces the risk of being fooled. This at-home protocol is powerful because it's based on immutable physical properties. A diamond will always have hardness 10 and a density close to 3.52. It doesn't matter if it's cut or rough, clean or covered in clay. These traits don't change. Fakes may mimic brilliance, color, and even cut, but when it comes to physical proof, they fail. Many people don't realize that major diamond discoveries often began this way, with someone curious testing a stone that looked worthless and noticing it behave differently. In the 19th century, during the first diamond rushes in South Africa, entire families sifted through gravel and manually tested hardness and density. That's how plain-looking stones turned out to be diamonds weighing dozens of carats. The same story still plays out today in small-scale mining areas. It's important, however, to stress that each test must be done carefully. When scratching glass, don't use excessive force that could break both the glass and the stone, sending shards flying. The scratch should be firm but controlled. In the density test, avoid air bubbles clinging to the stone's surface, as they can alter results. Always dry the stone before weighing, and repeat the process 2 or 3 times to ensure consistency. Once you master this sequence, fire, hardness, and density, you create a strong barrier against mistakes and greatly increase your chances of not overlooking something truly valuable. It doesn't matter if you found the stone on a dirt road, in a riverbed, or inherited it without knowing what it was. These tests are within your reach and are enough to separate with high confidence what's worthless from what could change your life. And the most striking part is that all this knowledge can be applied without spending almost anything. With a lighter, a piece of glass, a simple scale, and a cup of water, you're already equipped to avoid being deceived. While many still believe diamond identification is impossible without being an expert, you now know there are practical, accessible ways to get very close to the truth. Finding diamonds in nature isn't about pure luck. It's about being in the right place and recognizing the signs most people overlook. The first step is to understand the geological setting where it actually makes sense to search. Diamonds form deep in the earth and reach the surface through rocks called kimberlite and lamproite, ancient volcanic pipes that acted as conduits. Over time, weathering alters these rocks. The fresh, bluish material is known as blue ground. As it oxidizes, it takes on a yellowish aspect, the yellow ground, where collecting is often easier. These formations are mostly found in stable cratons, very old portions of the Earth's crust. In the United States, for example, the Wyoming Craton and parts of Colorado have produced historic finds. But a diamond prospector needs to go beyond maps. There are field indicators that shout stop and look. Among them are heavy minerals that typically occur with diamonds and kimberlites and secondary deposits. Chromium-rich garnets, chromite, ilmenite, chromium diopside, and pyrope. The combined presence of these minerals in gravels or soils is a valuable alert that the area may be connected to diamond-bearing pipes. If you pan or wash sediment and see bright red garnets mixed with dark grains of ilmenite, an attentive explorer knows they're not in an ordinary spot. Rough diamonds themselves also have distinctive features that make them recognizable. They may show curved faces, often forming rounded crystals in rhombododecahedron shapes, or edges worn down by river transport. Another key clue is their greasy luster, different from the glassy look of quartz or common glass. When wet, a diamond tends to keep that oily appearance, while other minerals simply look wet. Beyond primary kimberlite sources, rivers act as natural concentrators. Because diamonds are relatively dense, they accumulate in specific spots known as secondary deposits. In old channels, inner bends of meanders, plunge pools at the base of waterfalls, and behind large boulders in riverbeds, water flow slows down and heavy minerals collect. The so-called lag layers, compacted pavements of gravel, are also strategic places. Often, small concentrations remain preserved in cracks of bedrock for for thousands of years. To investigate these environments, collecting needs to be practical and systematic. Screening with progressively finer meshes is the first step, eliminating coarse material and retaining the fraction that may contain heavy minerals. A gold pan also works well for separating heavies from lights, leaving behind what's worth examining. In more organized setups, grease tables or oily fabrics are often used, since diamonds are hydrophobic and tend to stick to greasy surfaces while other minerals wash away. With concentrated material in hand, a 10 times loop becomes indispensable. Under magnification, you can check for true adamantine luster, curve fractures, absence of internal bubbles, and resistance to marks. If a sample looks suspicious, just apply the sequence you already know: fire, hardness, and density. This chain of tests eliminates most doubts and helps avoid throwing away a valuable find by mistake. In the United States, there's even the advantage of public digging sites. The most famous example is Crater of Diamonds State Park in Arkansas, where anyone can dig, screen, and keep what they find. It's one of the only dig and keep parks in the world, meaning everything you discover is yours. Not surprisingly, many large diamonds have been found there by ordinary visitors. Proof that this isn't a myth, but a real opportunity. In addition, parts of the Wyoming, Creighton, and Colorado are known for old pipes and indicator mineral trains that help guide local prospecting. One aspect that can't be ignored is legality. Every country, state, or county has its own rules. It's essential to respect permits, avoid private land without permission, and understand environmental regulations before collecting. Looking for diamonds without authorization can lead to serious problems, even if the discovery itself is legitimate. Ethics and respect for the law are fundamental parts of the practice. Finally, there's a very common mistake that must be mentioned: confusing milky quartz or clear calcite with diamonds. At first glance, they can look similar, especially when water-worn in gravel. But quartz is lighter, with a density of about 2.65, and it doesn't scratch glass as cleanly. Calcite is even softer and reacts easily to weak acids, like vinegar, by fizzing bubbles. Paying attention to these simple details prevents frustration and greatly increases the chances of recognizing a real diamond. Now imagine that after watching this video, you're walking along a dry riverbed and you come across a small transparent pebble among quartz fragments and dark gravel. At first glance, it doesn't look like much, but you decide to test it. First, it resists fire without showing cracks or cloudiness. Then it scratches glass with ease, leaving a sharp, permanent mark. Finally, you measure its density in a cup of water and get something close to 3.5. Every detail seems to confirm it could be a rough diamond. And this is exactly the moment when the inevitable question arises: what do you do now to avoid losing money? This dilemma is far more common than most people think. Many beginners stop right here, caught between the excitement of discovery and the insecurity of not being absolutely sure. And it's in this gap that opportunists move in. They approach with a rehearsed line: "That's worthless, it's just quartz." And they offer a token amount to take the stone off your hands. What might feel like an insignificant sale to you could actually mean losing something worth as much as a car or even a house. There are real cases of diamonds sold as glass and rubies traded away for pocket change, simply because the finder didn't have the right knowledge. The risk of confusion is real. Milky quartz, clear calcite, and even some natural glass can look like diamonds at first glance. Without a method, it's easy to make mistakes. But here's the important detail. Diamond isn't the only valuable stone you might come across. Even when a sample doesn't confirm as diamond, it could be sapphire, ruby, spinel, or even a gem-quality garnet, all of which carry significant market value. The problem is that without information, many people discard what could have been used, or sell for pennies what could have been worth thousands of dollars. That's why practical, organized information is worth more than any guess. To help avoid these mistakes, we created the channel's Field Guide, a straightforward tool designed for real-world use, showing in detail how to apply the tests you've just learned and many more. Inside, you'll find simple checklists so you don't skip steps, density tables to compare your results, real photos of indicator minerals, and examples of rough stones to train your eye. It's like having a pocket manual that turns curiosity into confidence and protects you from traps. With this guide, you won't have to rely solely on the word of someone trying to buy cheap. You gain independence to know what you're holding, to negotiate clearly, and to avoid the tricks that repeat themselves every day. After all, it's not enough to simply find a valuable stone. You need to recognize it and make sure it's valued properly. And this is only the beginning. Because even once you can tell a diamond apart from quartz or cubic zirconia, there's an even bigger challenge ahead: avoiding the most common mistakes made at the moment of selling. These mistakes make people lose small fortunes simply because they don't understand market details, evaluation processes, and basic identification techniques. And that's exactly the topic of our next video. We'll reveal the most frequent errors that turn valuable discoveries into financial disappointments, and how you can protect yourself from ever falling into those traps. So the next time you find a suspicious stone that survives fire, scratches glass, and shows the right density, remember this: the real risk isn't being wrong about whether it's a diamond. The real risk is not knowing what to do afterward and letting someone walk away with what could have changed your life. Thanks for liking and subscribing. Good luck, Gem Hunter. Hello, Gem Hunter. Would you believe me if I told you that there are many gems lost in nature, just waiting for the right opportunity to be found? Well, of course, the type of gemstone that can be found depends on the region you live in. But if it seems hard to believe, you should know that most of the great gems ever discovered, like this beautiful yellow diamond, were found by ordinary people. Some of these stones were so rare that when they were cut, they were auctioned off for thousands of dollars, like this ruby that is now appearing on your screen. But before we go any further, let me ask you a question. If you found a sapphire or a ruby in a river, would you be able to recognize it? Well, if the answer is no, then this video is for you, because today I'm going to show you how to identify these two gems if you find one of them lying around. Now imagine for a moment that you're walking along the banks of a river and you come across a dull, unremarkable stone. But after looking at it and seeing that it looks like an ordinary stone, you just throw it away. But what you may not know is that this stone could be a precious jewel. And if this has never happened to you, you can be sure it has happened to someone you know. Unfortunately, this situation is more common than you might think. And here's why. Not all precious gems are found in nature in polished and obvious form. In general, most precious gems are irregular, opaque, or very dirty, encrusted or trapped inside other minerals. That's why you need a closer look to find these gems. But what do you need to know to develop that closer look? Well, take rubies, for example, which are rare, precious stones that can even be found in the rivers where you live. Now look at this rough specimen and notice how imperfect it is, with some inclusions. So when you notice another stone, clean it well and keep it with you until you're sure what mineral it is. This applies to sapphires, diamonds, agates, and almost any type of precious mineral you might be lucky enough to find. First, it's important to note that rubies and sapphires are actually the same mineral, corundum. This mineral is composed of oxygen and aluminum, with small impurities that give these stones their characteristic colors. On the Mohs scale, which measures the hardness of minerals, corundum is just below diamond, with a hardness of 9, while diamond has a maximum hardness of 10. This makes corundum the second hardest mineral in the world. Rubies and sapphires are essentially the same. The main difference between them is their color. Rubies are always red, while sapphires can come in a variety of colors. Therefore, if you find a ruby in a certain region, it is very likely that you will also find sapphires, as both minerals are formed under similar geological conditions. It's worth noting that rubies and sapphires are extremely highly valued on the gemstone market, but this is only true for high-quality gems. As with diamonds, the value of these stones depends very much on the intensity of the color and the degree of crystallization. More crystalline stones with intense colors tend to be much more valuable. Not every ruby or sapphire found in nature is of high quality. Stones with a weak color or that are not suitable for cutting are known as industrial rubies. These stones, while not valuable as gemstones, are very useful as abrasives due to their hardness. However, don't be discouraged if you find an industrial ruby. It could be an indicator that with further exploration, you may find a very high-quality ruby or sapphire in the same area. But how do you know where to find rubies or sapphires before you go looking in some river? First of all, it's important to learn to recognize the indicators of these stones, which apply to any type of terrain. There are natural clues that can guide you, and these clues are the minerals associated with rubies and sapphires. By identifying these minerals, you increase your chances of being in a region rich in precious stones. One of the main clues is the presence of white quartz, which we talked about in an earlier video. This mineral usually occurs in areas where rubies and sapphires are also found. Also look for schist and mica schist, which are shiny, fragile materials that crumble easily when touched. Mica in particular is an excellent indicator. It comes in a variety of colors, and the more mica you find, the more likely you are to be near rubies or sapphires. Another important mineral to identify is pegmatite, a rock related to granite and composed of quartz and feldspar. It is hard, full of visible granular inclusions, and usually gray in color. Depending on your region, you may even find large walls of pegmatite. Also look for aluminous gneisses, gray rocks with long striations that contain large amounts of aluminum, the main element in the formation of rubies and sapphires. Zoisite, a light green mineral, is also often found in association with rubies. Green stones with pink flecks can be a strong sign that you are in an area with potential for rubies. And if you see basalt, marble, and granite in the area, this could also indicate the presence of these gems. Remember, the more of these indicators you find, the better your chances of finding rubies or sapphires. So the next time you go gem prospecting, keep these signs in mind and be aware of the nature around you. Now you know how to tell if a river near you has sapphires or rubies. But regardless, we're going to show you how to recognize these stones in practice, right in the rivers. Finding a ruby or sapphire, even if it's not the best color, is an excellent sign. This is because the stones in the rivers undergo a kind of natural selection. The higher quality gems are stronger and more resistant, while the lower quality gems are more fragile and break over time. Over the years, the more fragile stones are eliminated by contact with other rocks, while the more durable stones remain intact. Here are a few examples of stones found in Brazil. At first glance, they look like ordinary river stones, but they are actually sapphires. Although the colors are not as vivid, the size of these stones can add value, as they are rare in such dimensions. Another example is these grayish-green stones, another type of sapphire that comes from rivers. Now guess what these reddish stones are? That's right, they are rubies. Notice that the color is a pinkish red, not very intense, but noticeable. Although they are not of the highest quality, they can become valuable after cutting, like the stones you see on your screen now. Here are some of the rubies we showed you earlier, now cut and ready for sale. But how do you identify a stone like this? How can you tell if it's a ruby or a sapphire? The first thing to look at is the weight. Rubies and sapphires are dense gemstones and can weigh almost twice as much as an ordinary stone, such as quartz, jasper, or agate. This difference in weight means that these stones tend to accumulate in rivers with other heavy minerals such as ilmenite and chromite, a dense mixture of iron and titanium. This phenomenon occurs because, over time, rivers cause the heavier stones to concentrate in cavities, while the lighter stones are carried away by the current. Another mineral that can indicate the presence of rubies and sapphires is garnet, a reddish gemstone that is also quite heavy. However, it is important not to confuse garnet with ruby. The red of rubies is more pinkish, while that of garnets is more brownish. A handy way to identify rubies is to use an ultraviolet flashlight. When exposed to this light, rubies usually glow an intense pink, while other stones remain the same color under UV light. However, this test is specific to rubies, as sapphires do not react to UV light in the same way. In addition, a crucial characteristic to observe in rubies and sapphires is the stone's DNA. This term refers to the presence of unique patterns on the surface of the stones that act like a fingerprint. Rubies and sapphires often have a network of intersecting lines, similar to a game of tic-tac-toe. Take, for example, these samples of cut gold and sapphires, where the lines are clearly visible. In some cases, it is also possible to observe the asterism effect, where a star of light appears on the stone under illumination. This pattern is not always obvious, so it is important to carefully inspect any heavy stone you find. A magnifying glass can be useful to see these characteristics in more translucent or lower quality stones. Another detail to look for are the spiral patterns that can appear on some gemstones. These patterns are characteristic and deserve special attention, as they may indicate that you are holding a gemstone. And finally, be careful if you find a broken stone. Rubies and sapphires are extremely tough and hard, which means they don't break easily. Unlike other gemstones, such as quartz, jasper, or agate, which when broken tend to produce a smooth, shiny fracture similar to glass, rubies and sapphires have no cleavage. And when they do break, they do so in a totally irregular manner, with dull edges and little shine. This is an essential characteristic for distinguishing them. If you find a stone that looks dull and uneven, don't be too quick to dismiss it. It could very well be a ruby or a rough sapphire. Also remember that the presence of a lower quality stone may indicate that you are in a promising environment where high quality gems can also be found. Another important point is the location of the search. Rubies and sapphires tend to accumulate in certain areas of rivers, such as bends, shallow areas, or where the current slows down, as these areas facilitate the accumulation of heavy materials. So you should observe the behavior of the river and map areas where gravel accumulates, because these are the places where heavy minerals, such as rubies, diamonds, and garnets are deposited, hidden under the gravel, just waiting for someone to find them, which means that this information can make all the difference in your search. And remember, the key to finding any gemstone is knowing the right signs. This includes not only knowing the weight and density of the stone, but also understanding the geological context around it. If necessary, I recommend that you watch the video again, write down the key points, and return to the field with these tips in mind. The more knowledge you have, the better your chances of success. Many people with a little courage and a willingness to venture out end up finding many hidden treasures in nature. Whether it is a simple walk through the woods or along the banks of a river, many of our subscribers tell us in the comments about the gems they find. So if you'd like to start this therapeutic hobby that keeps you in touch with nature and gives you the opportunity to earn some extra income, I'd encourage you to start right now. Who knows, you might even discover a new mineral deposit out there. And to help you identify these stones, there are several complete videos here on the channel about different types of gemstones, including diamonds, with home tests to help you get to know the stones you find out there better. But if you want all this knowledge organized in one place, by accessing the first link in the description of this video, you can purchase our digital book, Gemology for Beginners, a complete and illustrated material containing the Dictionary of Minerals, where you will learn the main characteristics of all the precious and semi-precious stones that exist in the world. Thank you for liking and subscribing. Good luck, Gem Hunter. When people think about gemstones, the usual names come up: diamonds, rubies, sapphires. But today's video is about the ones that almost never make the spotlight. Gems so unusual, so unexpected that most people don't even realize they occur in nature. And here's the twist. Some of these ultra-valuable stones might be hiding much closer than you think, in riverbeds, gravel pits, hiking trails, or even right in your backyard. That's why you should pay close attention. In today's video, we're going to explore 7 valuable gemstones you'd never guess are found naturally, so you'll know exactly what you're looking at if one of them ever appears in your region. When it comes to finding gemstones in the wild, there are 2 things you must understand from the start. First, how a mineral looks in its raw, unpolished form, and second, the geological signs that reveal you're close to something valuable. So imagine you're out exploring, and you stumble upon a strange, shiny crystal you've never seen before. How do you know if it's rare? How do you know if it's one of these 7 high-value gems? That's where understanding texture, luster, hardness, and color variations becomes essential. Some gemstones even glow under UV light, show unique internal patterns, or react differently when you scratch them against harder minerals. And believe me, each of the 7 gems we'll talk about today has something unusual about it, something that makes it stand out even before it's cut and polished. Their characteristics are so fascinating that they couldn't all fit in just one video, which is why we'll focus only on the most surprising ones today. If you want to go deeper into the subject, you can find our Gemology ebook in the first link in the description. Now let's imagine you already know what a ruby looks like and its specific characteristics in its raw state. How would you go about locating one? Now we come to the most important part, indicator minerals. These are typically volcanic rocks that can appear as fragments or massive formations, sometimes stretching for kilometers. For instance, if you're looking for a diamond, you might try to locate kimberlite rocks because these rocks originate from the same place where diamonds are formed. In other words, the logic here is simple. If you want to find topaz, you need to know what type of rock forms under similar conditions. The first gemstone on our list is turquoise, one of the most fascinating and recognizable gems in the world. Its color typically ranges from sky blue to bluish green. If you hold one in your hands, you'll notice that its surface feels smooth and pleasant to the touch. The texture is usually even, but may feature small veins or web-like patterns caused by inclusions of iron or manganese oxide, depending on the stone's origin. In terms of hardness, it's relatively low, ranging between 5 and 6 on the Mohs scale. According to experienced geologists, these markings, known as a matrix, can further enhance the gem's beauty and make it unique. Additionally, turquoise has a waxy luster and is relatively opaque, giving it a distinctive appearance among gemstones. If you're searching for turquoise in nature, identifying their presence in an area can be aided by certain minerals. Turquoise typically forms in dry, arid environments and is found in veins and cavities associated with volcanic and sedimentary rocks. Minerals like limonite, iron oxides, and quartz are often found nearby, as well as chrysocolla, which shares a similar formation environment. These minerals can indicate that the soil has the ideal chemical conditions for the formation of this precious gem. Furthermore, the presence of large amounts of copper is essential, as this element gives turquoise its characteristic bluish hues. So if you find copper-rich minerals in your area, such as malachite or azurite, there's a good chance that turquoise may be hidden nearby, nestled among the layers of the terrain. The second gemstone on our list has already been mentioned and couldn't be left out, as rubies are, without a doubt, one of the most important gems in the world, not only for adorning jewelry, but also for their industrial applications. The first thing you'll notice about rubies is their striking pinkish red color, which can range from a lighter, more vibrant shade to a deep red, depending on the concentration of chromium, the element responsible for the gem's color. If you hold one in your hand, you'll notice that it's a relatively heavy stone. To the touch, the surface of a ruby is smooth and polished, with a vitreous luster that enhances its sophisticated appearance. However, if the ruby has been river tumbled, it often has a matte finish with an irregular surface. What truly stands out, though, is its incredible toughness. With a hardness of 9 on the Mohs scale, ruby is one of the hardest natural stones, second only to diamond. This durability, combined with its beauty, makes ruby a popular choice for both jewelry and practical applications. In the industry, for instance, rubies are used in lasers, high-precision watches, and abrasive materials such as sandpaper and polishing wheels. So rubies are much more than just a beautiful gemstone. They're also a valuable tool across various sectors. To find rubies in nature, it's important to pay attention to the characteristics of the environment where they typically form. Rubies primarily originate in metamorphic rocks, such as aluminum-rich marbles, and in some igneous rocks. Minerals like spinel, feldspar, and calcite are often found nearby, indicating that the environment may have the right conditions for ruby formation. Additionally, finding chromium-associated minerals like zoisite can be a good sign. By paying close attention to these clues, you might just stumble upon a ruby hidden among the rocks or rivers in your area. But what if you spot all these signs and don't find a ruby? In that case, you might have come across a sapphire instead. After all, the only difference between a ruby and a sapphire is the color. While rubies showcase their red hue thanks to chromium, sapphires can range from deep blue to lighter shades or even unconventional colors like yellow and pink, depending on the trace elements present in the stone. Both rubies and sapphires are varieties of the same mineral, corundum, and they share the same Mohs hardness of 9, which means sapphires are also extremely durable and highly valued for both jewelry and industrial uses. So even if you don't come across the vibrant red of a ruby, finding a sapphire is far from disappointing. In fact, it's an excellent discovery, as sapphires have a market as strong as rubies and can be equally valuable depending on their quality. Therefore, when exploring areas rich in minerals like zoisite, feldspar, and other indicators, remember that the conditions favorable for ruby formation are also conducive to sapphire creation. However, when finding rubies or sapphires in nature, it's very likely that you'll come across low-quality specimens. These gems, when they lack the purity or coloration necessary for use in jewelry, are typically classified as industrial grade and are destined for technical applications. But does that mean you should get discouraged and abandon your search? Not at all. In fact, finding a lower quality gemstone can be a great sign. This holds true for any type of gemstone. If you found a low quality one, it's highly likely that the area has potential for higher quality gems. Think of it as an indicator that you're on the right path. Nature rarely reveals perfect gemstones right away, but with patience and persistence, you may end up discovering a high-quality specimen. It's all about continuing to explore and learning to recognize the right signs. The fourth gemstone on our list is the emerald, one of the most sought-after gemstones throughout history. Known for its intense green hue, which can range from a vibrant green to a lighter or slightly yellowish green, the emerald captivates with its unique color, a result of chromium and vanadium. When observing an emerald, it's common to notice small inclusions inside it, known as gardens. Far from being considered flaws, these natural marks are seen as features that make each stone unique and special. To the touch, emeralds have a smooth surface and a vitreous luster that enhances their natural beauty. However, compared to other gemstones like rubies and diamonds, emeralds are relatively fragile, with a hardness of 7.5 to 8 on the Mohs scale. This means that while they are durable, they require some care during cutting or use in jewelry to avoid cracks or damage. If you're searching for emeralds in nature, there are a few clues that can help. They typically form in metamorphic environments or hydrothermal veins, where beryllium-rich rocks like pegmatites and schists are present. Minerals such as quartz, calcite, and phlogopite often appear alongside emeralds, indicating you might be in the right spot. Additionally, the presence of chromium or vanadium in the soil is essential to give emeralds their characteristic color. So if you come across beryllium-associated minerals or notice signs of hydrothermal deposits, it's worth investigating carefully, even if the first stones you find aren't of high quality. Just like with rubies and sapphires, you might also come across the next gemstone on our list: diamonds. And if you're exploring alluvial deposits, your chances increase significantly. That's because diamonds, despite forming at extreme depths, are often brought to the surface by volcanic processes and then transported by rivers and streams, accumulating in areas where the water flow slows down, such as riverbeds or valley floors. Diamonds have very distinct characteristics, known for their metallic luster that stands out even in their raw form and their incredible hardness. The highest among all natural gemstones, with a perfect 10 on the Mohs scale. Visually, rough diamonds may not appear as impressive as their polished counterparts. They often have a translucent or even opaque appearance and typically exhibit natural geometric shapes, such as the classic octahedron. Additionally, diamonds are dense, with a high specific gravity compared to other minerals. Because of this, they tend to settle at the bottom of gravel beds and in areas where heavier materials accumulate, such as pits or depressions in riverbeds. To find diamonds in nature, it's helpful to know the indicator minerals that might be present. Minerals like garnet, pyroxene, and olivine are important clues, as they often form alongside diamonds under extreme conditions and are usually associated with kimberlite pipes, the volcanic formations that transport these precious stones from the Earth's depths to the surface. When these minerals appear in alluvial deposits, it's a strong indication that you might be in a location with diamond potential. Even if the first diamond you find is small or industrial grade, that's no reason to lose motivation. As with other gemstones, finding even an imperfect specimen is a sign that the area has potential for more valuable gems. It's also possible that you may encounter garnets or distillates in the region. While these gems are not as valuable as diamonds, they still hold their worth, especially when they display vivid colors and unique characteristics. For this reason, if you come across some colorful stones, it's essential to seek the help of an experienced gemologist or at least a seasoned prospector. They can help you correctly identify your finds and even assess their potential value. However, we know that finding a qualified professional isn't always easy. That's exactly why we've compiled all the gemstone knowledge from this channel into one convenient place. And so the book Gemology Journey for Beginners was born, a complete guide that gathers everything you need to confidently identify gemstones in nature. The book includes detailed explanations, illustrative images, and practical tests you can do at home without any expensive equipment. It was designed to make gemology simple, accessible, and intuitive, helping both beginners and enthusiasts deepen their understanding of the gemstone world. But if now isn't the right time for you to get the book or join the channel's members area, you can still keep learning for free by subscribing to the channel and watching the upcoming videos. Every week I share new tips, techniques, and information to help you identify and find gemstones, even if you've never had contact with this world before. After all, knowledge is what turns an ordinary stone into a valuable discovery. I also want to give a special thank you to the channel members, to everyone who leaves a like and subscribes, and especially to those who support us by getting the book. It's thanks to that support that I can continue producing content like this, exploring locations, sharing discoveries, and bringing you information that can completely change the way you see the stones around you. Good luck, gem hunter! Imagine you're in a survival situation and your goal is to find raw diamonds in the wild. What would you do first? And more importantly, where would you even start looking? Well, it's definitely not an easy task, and there are many different ways to go about it. So in today's video, I'm going to show you the easiest method to locate rough diamonds in nature and reveal all the geological clues you need to follow to track down these precious gems. You probably already know that diamonds are among the most valuable gemstones in the world. But what you may not know is where exactly they leave traces in nature and how to recognize the geological signs that can lead you straight to these hidden treasures. That's why it's crucial to understand exactly what these signs are and what types of terrain or rock formations deserve your full attention before you even start searching. And I'll also show you how to identify a raw diamond in nature using simple tests you can do at home. Because when it comes to finding precious stones in the wild, knowing where to look is only half the journey. The other half is knowing what a real diamond looks like before it's ever cut, polished, or turned into luxury jewelry. Now picture yourself standing at the edge of a river, your feet in the water. Suddenly you look down and notice a small, shiny stone resting on the riverbed, slowly being nudged by the current. It looks like a diamond coming straight toward you. Of course, this is just a fictional scene, because in real life, you'll never see a diamond casually floating down a stream. And here's why. The very first sign that a stone could be a diamond is its weight. Even when they're small, diamonds are much heavier than ordinary rocks of the same size. This means diamonds don't get swept away easily like other stones. Unless the current is extremely strong, a diamond won't travel far. It sinks quickly and gets buried beneath the gravel, especially in what we call alluvial deposits. But does that mean you could find diamonds anywhere in a river? Not quite, but it's not impossible either. There are specific areas within rivers where the odds are much higher, and those are the spots where diamonds and other valuable gems tend to build up over time. These places are known as alluvial zones, or alluvial deposits. These deposits can take thousands, even millions, of years to form. Here's the logic behind it. As the river erodes the soil over time, it breaks down rocks, often volcanic, especially during heavy rains or floods. The powerful current carries away the lighter particles and pushes the heavier ones along until the water slows down. When that happens, the heavier materials settle, while the lighter ones keep moving downstream. And it's in those quiet pockets that the densest gravel collects, including diamonds, gold, sapphires, and even rare minerals like titanium. And if you're thinking this only applies to rivers with flowing water, here's a little secret you need to know. There are ancient rivers that dried up centuries ago, but they left behind alluvial gravel that often hides valuable gemstones. So the real trick is knowing how to spot where the heavier gravel settled. Once you identify those areas, you can collect the material and use the techniques I'm about to show you to increase your chances of finding real diamonds. And the best part? Even if you don't strike a diamond, following this process could lead you to other precious stones like rubies, sapphires, tourmalines, and more, all of which can be just as valuable depending on size and quality. But if you really want to find high-value diamonds in your area, the first thing you should avoid is looking for diamonds directly. Yes, you heard that right. I know it sounds counterintuitive, but think about it. Trying to find a diamond without knowing what to look for is like searching for a needle in a haystack. Your odds are extremely low. However, unlike a needle, diamonds come with natural signposts, and these are called indicator minerals. And that's what you should be looking for first. Because without these minerals, it's almost impossible to know whether diamonds are even present in your region. So is this hard to do? Not really, and I'll show you the trick in just a minute. But first, let's break down what these indicators actually are. Basically, indicator minerals are heavier, more common rocks and minerals that form under the same extreme geological conditions as diamonds. That means if you spot them, there's a good chance diamonds could be nearby. The three most important indicator minerals you should learn to recognize are garnet, ilmenite, and chromite. These are far more common than diamonds, but they show up in the exact same geological environments. So spotting any of them is like seeing an arrow pointing in the right direction. Let's start with garnet, especially the pyrope variety. It's one of the easiest to identify. Pyrope garnets are usually reddish or orange, sometimes darker or brownish. In rivers, they often appear as rounded, faceted, or even cube-shaped pebbles, sometimes polished by water. While garnets can be gemstones themselves, and even valuable, their main role here is to signal a promising location for diamonds. Next is ilmenite, a dark, almost black mineral with a dull metallic shine that can look like polished iron. It's dense, heavy, and typically shows up in irregular shapes with a few flat faces. On the Mohs scale, its hardness is around 6, meaning it can be scratched by a quartz crystal, which is 7. That makes it easy to test in the field using a simple quartz tip or sandpaper. Then there's chromite, which is also dark but with a rougher surface and less shine than ilmenite. It's even heavier, more opaque, and often has an irregular lead-like texture, almost like raw iron ore. Finding chromite, especially in areas with volcanic history or ancient riverbeds, is another strong sign that you're standing above precious ground. These three minerals often show up together in river gravels and ancient alluvial deposits, and they're way easier to spot than diamonds themselves. That's why learning to recognize them is such a key step in diamond hunting. Here's a practical tip. Every time you spot one of these minerals, mark the location, collect a sample, wash the gravel carefully, and use a set of sieves to isolate the heavier material. Whatever remains at the bottom could reveal even more clues. Or if you're lucky, a real diamond. Now here comes the real secret. Once you've identified the indicator minerals and confirmed that you're in a promising area, it's time to get your hands dirty, or better yet, wet. And while the idea of extracting diamonds from the earth might sound complicated, the truth is, the process is a lot simpler than it seems. All you need is a basic set of sieves, a bit of focus, and some patience. Ideally, you'll want 3 to 6 sieves with different mesh sizes. A coarse one for the larger rocks, a medium mesh for mid-sized gravel, and a fine mesh, which is where many diamonds like to hide. Start by collecting gravel from the riverbed or along the banks, especially in bends, deep pools, or slower-moving sections. These spots are perfect because that's where heavier minerals tend to settle. Once you have the material, place it in your largest sieve and begin to shake it in a gentle circular motion, letting water flow through the gravel. This movement helps wash away lighter particles like sand and small debris, leaving only the densest material at the bottom. With a bit of practice, you'll start to notice something. Even when collecting the same amount of gravel, the material that settles in the center of the sieve is always darker and heavier. And that's where you'll find garnets, ilmenite, chromite, gold, and yes, possibly a diamond. If you're working in a river with flowing water, the current will help do some of the separation work for you. But if you're prospecting in a dry riverbed or old alluvial deposit, just use a bucket of clean water and repeat the same process manually. Now here's the most critical part. Examine what's left at the bottom of your sieve with extreme attention. Diamonds don't look like other stones. Even the darker or oddly shaped ones have a unique kind of shine, a metallic glow like polished steel. One trick experienced prospectors use is to rotate the sieve slowly during the final rinses. This helps center the heavier materials, making them easier to spot. And don't be fooled by size. A diamond weighing just 1 gram is already a fantastic find. Even smaller ones, known as industrial diamonds, are proof that you're in the right place. And if you find one, don't stop. Keep digging, keep sieving. Because where there's one diamond, there might be more. And believe it or not, finding a lot of small diamonds can sometimes be even more profitable than hunting for a single big one. If you're searching in a river with flowing water, your chances just got even better. Because now I'm going to show you how to tell the difference between hundreds of ordinary stones and the ones that might actually be diamonds. When it comes to diamonds found in nature, especially in rivers, it's important to manage your expectations. You're not going to find a perfectly cut, sparkling gemstone like the ones you see in engagement rings or jewelry store windows. A rough diamond looks completely different. Most of the time it appears irregular, with rounded edges, sometimes even slightly polished, as if it's been sanded down by the river itself. That's because even though diamonds are the hardest minerals on Earth, they still get worn down by constant collisions with other rocks. So how do you tell the difference between a rough diamond and just another river stone? The first clue is its metallic luster. While most stones reflect light with a glassy shine like quartz or topaz, a diamond has a much more subtle, dense shine. It looks oily, metallic, almost like a polished piece of steel rather than a gemstone. This difference becomes obvious when you compare them side by side. Take a piece of quartz and place it next to a rough diamond. Quartz will look clear, almost like glass. The diamond, on the other hand, looks more opaque, but with a deeper, more intense reflection. Now that you know what to look for in the appearance of a rough diamond, the next step is to test its physical properties, to make sure that what you found is actually the real thing. One of the simplest and most effective tests you can do at home is the sandpaper test. For this, you'll need a coarse sandpaper, the kind you can buy at any hardware store. Look specifically for sandpaper made with carborundum, a material with a Mohs hardness rating of 9. That means it can scratch almost any stone, except for diamond, which scores a perfect 10 on the Mohs scale. To run the test, hold the stone firmly and rub it against the surface of the sandpaper with pressure. If the stone resists without any visible scratches, there's a good chance it's a diamond. But if it leaves behind a white powder or develops scuff marks, that means its hardness is lower, most likely quartz or plain glass. Another helpful test is light refraction. Shine a flashlight or any strong light source on the stone and observe how the light moves through or reflects off it. Diamonds have a very high refractive index, which means they bend and scatter light in a way that's totally unique. Even in rough form, you can sometimes see the light dance inside the stone, very different from the clear and even transparency of quartz crystals. If you have access to a precision scale, you can also compare the weight of your stone to other stones of similar size. As mentioned before, diamonds are extremely dense, and that density is noticeable when you weigh them side by side. Now here's something important. These home tests are incredibly helpful, but they're not 100% conclusive. So if your stone passes the sandpaper test, shows that metallic, oily shine, feels heavier than normal, and has a crystal shape typical of diamonds, do not rush to sell it. Instead, store it safely and, if possible, send it to a professional lab for analysis. A diamond certified by a trusted gemological lab, like the Gemological Institute of America, can be worth significantly more than one sold without verification. But what if your stone doesn't pass the test? Should you just throw it away and give up your search? Absolutely not. Here's the truth. The same indicator minerals that lead to diamonds often form in the exact same environments as other precious stones, some of which can be just as beautiful, rare, and valuable. Take garnets, for example. Not only are they a clear sign that you're in a promising location, but many garnets, especially pyramid garnets, are gems in their own right. When well-formed and translucent, they can be cut and polished into stunning jewelry stones, selling for anywhere from tens to hundreds of dollars, depending on size and quality. Another great example is spinel. Though rare, it's often found alongside garnets and chromite. Spinel has famously been mistaken for ruby, even by experts. It can appear in deep red, pink, blue, and even clear varieties. And some spinels are extremely valuable on the gem market. Then there's zircon, often underrated, but absolutely worth your attention. Natural zircon can show up in heavy mineral zones and is known for its golden, orange, or even reddish tones. When cut properly, high-quality zircon can be surprisingly valuable. And if you happen to be in a volcanic region or in an area with complex geological history, you might even come across sapphires or rubies, especially if the indicator minerals are present in good concentration. It's rare, sure, but not impossible. In fact, chromite, which often signals diamond potential, can also point to corundum-rich environments. And corundum is the base mineral for both sapphires and rubies. Even if the stone you find doesn't have high market value, the experience of discovering it, learning its story, and understanding the geological journey it took to reach you, that alone makes the hunt worthwhile. But before you go out searching every riverbed or gravel patch you find, here's one thing you absolutely need to know. Never throw away a stone unless you're sure what it really is. I get it. Identifying minerals can be hard, especially when there are hundreds of different gemstones out there. But believe me, some of our subscribers have shared stories where they unknowingly threw away or sold valuable gemstones for just pennies, simply because they didn't recognize what they had in their hands. Unfortunately, there are buyers out there who will take advantage of that, paying far less than what your stones are actually worth. That's exactly why I created the Gemology Journey for Beginners ebook, a complete, easy-to-follow guide for anyone starting out in the world of gemstone hunting. Inside, you'll learn how to identify raw diamonds, distinguish them from common crystals, and perform simple tests at home to check hardness, density, luster, and crystal structure, all using affordable tools you probably already have. This knowledge will give you the confidence to know exactly what you're holding before showing it to any buyer, so you don't fall into scams, or even treat your finds as a long-term investment. Originally, this material was designed for collectors, but we've since adapted it to help everyday people avoid being taken advantage of. And if your focus is collecting, you'll love the exclusive gem identification chart we've included. It covers dozens of minerals, their colors, densities, crystal habits, and rarity levels, perfect for anyone looking to grow in this journey. The full value of the ebook is $29.90, but right now I'm offering a special discount for channel subscribers. Get lifetime access for just $9.99. And the best part? You get a 7-day guarantee to read the full guide and decide if it's right for you. If not, just ask for your money back, no questions asked, no hassle. And yes, the download works no matter where in the world you live. Once you click the first link in the description, you'll be taken to a secure page with all the information clearly explained step by step. Plus, by purchasing the ebook, you'll be helping to strengthen this amazing gem hunting community we've built together. The Cabo de Now channel has grown so much lately, and it's all thanks to people like you. We've inspired thousands of people around the world to embrace this hobby, and now it's your turn to be part of it. But if you're not ready just yet, that's totally fine. Just hit subscribe and keep learning for free with us. In the next episode, I'll show you how to spot other hidden gemstones in your area, like jade, rubies, sapphires, and even tourmalines. And some of them can be worth more than diamonds. So thanks for liking and subscribing. Good luck, gem hunter. Diamonds are a highly coveted gemstone and are found in various places around the world, including Africa, Asia, North, and South America. We've already made a video here that shows 7 places that are open to the public where you can find diamonds and other gemstones such as rubies, opals, and sapphires, as well as other videos where I show you firsthand what indicates the presence of diamonds in a particular region. For example, garnets, diopside, mica, white quartz, kimberlite fragments, and other minerals that indicate the presence of diamonds. And in case you didn't know, one of the most accessible places to look for these indications I just mentioned is in rivers, including those that have dried up. And here's why. If you take a diamond and a river rock of the same size, the diamond is going to be much heavier. So as much as the current has the power to carry the diamonds for miles downstream, at some point that diamond is going to end up sinking between the river rocks and getting buried in the gravel. And I say that because you can find diamonds anywhere along a river as long as you look in the alluvial deposits, better known as alluvial fans. In other words, to simplify things, these alluvial deposits are the gravel that accumulates in the riverbeds and bends of rivers. But despite all this, people still have doubts about how to find and identify real diamonds in nature. No wonder, because finding diamonds, although rewarding, is not an easy task, as they are rare gems, since their formation depends on extreme pressure and temperature conditions. However, many of the places where diamonds can be found have never been explored. So in today's video, I'm going to answer all of your questions so that you have the minimum knowledge necessary to find out if there might be diamonds in the rivers in your region. So stick with me for a few more seconds because this video is going to change the way you look at things. Before you start, you need to identify the diamond indicators, which I'll explain in more detail below. But to start prospecting, all you need are sieves, which is certainly the easiest and cheapest way to start looking for diamonds. If you can get your hands on 3 or 6 different size sieves, you're good to go. But now let's talk a little more about the most accessible place to find a diamond, which is river alluvium. And to do that, you have to identify the minerals that are present in these alluvial deposits. Just look at how they are full of stones and gravel, sand and silt. That's where diamonds can get trapped, often buried by all that material because of their high density. So if you use the sifters that I've mentioned here on this river, you may be able to find a diamond or some other rare mineral like rubies and sapphires. And as I've said in other videos, these alluvial deposits were usually formed millions of years ago. And that's why diamonds and other precious minerals like gold and titanium can be buried in this alluvial gravel. Now answer me a question. Have you ever seen this type of gravel in a river in your area? If the answer is yes, then stay tuned because there is certainly a possibility of finding diamonds in your area. But don't get me wrong, the goal of this channel is to encourage you to develop this incredible and therapeutic hobby that keeps you in touch with nature. As I've said before, diamonds are hard to find, but this is the kind of information that can change your financial life forever if you find a good diamond in the wild. But the best diamonds are found in underground mines. And now you may be asking yourself, but how am I supposed to find a diamond in a river? Well, let me show you. Look at this rock here. This is the famous kimberlite rock. If you find one of these rocks in your area, there's a good chance you'll find diamonds nearby. These kimberlite rocks are nothing more than lava that comes from the Earth's mantle through volcanic eruptions. In this process, the diamonds that are formed in this region end up being brought along with this lava, which when it cools ends up trapping the diamonds inside. However, over the course of thousands of years, the forces of nature end up fragmenting some of the kimberlitic rocks, releasing the diamonds trapped inside. The diamonds are carried by the wind, torrential rains and downpours to the rivers, where they are deposited in the riverbeds or even on the beach. In the same way, diamonds that have been detached from a kimberlite by erosion and fallen into the riverbed can be carried to the beach by the current of the water. But what about diamonds found in rivers? Well, that's where you're going to need those sieves I mentioned earlier. You're going to find a clean spot with no rocks around. Then you're going to dig up the earth a bit to remove the gravel from the alluvial deposits. And you're going to start sifting the material. Start with the largest sieve and work your way down to the smallest, always keeping the smallest sieve under the largest so that the material that passes through the mesh of the largest sieve is caught in the smallest sieves. If you can get 5 or 6 degrees of screen, that would be even better. But let's assume for the moment that you're in an actual river with flowing water. Diamonds found in underground mines have a hexagonal shape with 6 sides like this. However, diamonds found in alluvial deposits whether in dry rivers or flowing rivers, are rounder than diamonds taken directly from kimberlites. Diamonds found in rivers look like a semi-polished stone. Despite being the hardest mineral on Earth, they also suffer from the effects of thousands of years of wear and tear from friction with the other stones in the river. But then you may ask yourself, how can I tell a diamond from other common stones? It's easier than it sounds. There is one characteristic that only diamonds have.